Well, in this episode, we're going to start working with metal on the project. We're going to make some custom photo-etched brass sheets. We're going to start working with tubing and other special shapes. And we will even start doing some soldering. So stick around. There are lots of fine, detailed parts on the Oceanic that lend themselves very well to the photo etching process. Things like ladders and railings, these life raft racks, vents like we see here on the funnel, various gussets and support structures, vents, doors, these crane booms and framework around the cabin, and even these lounge chairs can all be made with the photo etching process. So let's say we have this sheet of brass. If we were to drop it in a bath of ferric chloride, which is an acid, the brass would be eaten away and it would be gone. But if we were to put a mask on this brass, the section of brass underneath the mask would not be attacked by the acid. The other side, however, would be eaten away and it would leave a brass shape half the original thickness. And the result would look something like this. If we had put the same size and shape mask on the opposite side of the brass, then neither side of brass would be etched away underneath the masks. And we'd end up with something like this, a full thickness shape. Now if we put a different shaped mask on the other side, a different shape will be etched on the front than on the back. Remember that anything that's covered with tape stays brass and anything that is uncovered will be etched away. And this time we have the shape as the full thickness of the brass, and the oval is half thickness. Anything not covered by the mask gets eaten away, so anything outside of the oval, and also the eyes, will be etched through from both the front and the back. And those are the basics of photo etching, so back to the Oceanic. So I'll demonstrate this by making this set of steps right here. It's a 3-bar railing going up the side of the stairs with a little bit of a wider top and vertical railings on the two ends. So this is that set of stairs on the plans. I'll zoom in a little bit and measure to make sure that the scale of the plans is the right size. It should be 18 millimeters from one deck to the other. I'll also measure the width of this side piece on the plans as well. Zooming in more makes it easier to measure, and I can see that it's 1.56 millimeters in model scale. Now I'll draw a box that represents the size of the stairwell and a line that shows the angle of the stairs going up. When I imported the image of the plans into TurboCAD, I saved it as a separate layer, so it's easy to shut off to clean up the workspace a little bit. Now I'll make a parallel copy of this line with a spacing of 1.56 millimeters. And I'll trim all these excess lines to leave only the side railing profile of the stairway. Then I'll use the hatch command to fill this in with a solid color. So now we have the solid hatch and the lines that we used to make it. And sometimes this causes trouble, so I'm just going to erase the lines and leave the hatch. So now we've made this side piece to the stairway. Now from an imported image of the deck plan, I can measure the width of this stairway. And it's 7.12 millimeters wide. Just like before, I can shut off this plan to declutter the desktop a little bit. Now I'll make a line perpendicular to this side piece and exactly the width of the stairway. So an average stair step is about 20 centimeters or 200 millimeters. That works out to 1.39 millimeters in model size. Since there are 18 millimeters between decks, I'm going to use 13 stairs in my staircase. I'll use the divide by feature in TurboCAD to divide these side pieces into 13 equal sections that I'll put the steps on. The minimum line or gap width that the photo etching process can do is about 0.25 millimeters. That depends on thickness, but for the material I'm going to use, that's what it is. So I'm going to put a small box in each of the four corners to define the shape of the tread of this stair. And the size of that box is equal to the minimum line or gap width that the etching process can do. Now I'm drawing the stair's surface, and I can erase those four little boxes. Now I'll hatch the stair's surface to leave one stair step and one side profile. And here's something that's a little annoying about TurboCAD. The line that I drew with the line width of 0.25 millimeters shows up as a hairline. To illustrate this, I'll draw a rectangle 0.25 millimeters wide, and you'll see the difference. Here's the width of the rectangle and the width of the line. Both 0.25, but obviously they don't look the same. And this line is drawn to be 3 millimeters wide, even though it's obviously not. So you can't trust what you see on the screen, but it prints out properly. Now I'll copy this single stair 13 times up the side profile. Now we'll draw the hand railings, starting with the verticals. I'll make them 7.6 millimeters, which is 110 centimeters or 43 inches off of the floor at the bottom and the top of this staircase. And I'll draw the top handrail and make it a little bit thicker. I'll set it to 0.5 millimeters. And I'll use the divide by 3 feature to put 2 vertical railings at 1/3 and 2/3 of the way up this rail. And I'll check that each of these hairlines is actually the width that I want them to be. I'm going to put a small fillet or curved part between these two pieces of railing, and as an afterthought, I'm going to extend these railings out a little bit, just in case they don't perfectly line up with the railings on the upper deck. If they do line up perfectly, then I can easily just cut them off, but if they don't, I can bend them into shape. And now when I mirror the side support and the railing to the other side, I have a complete staircase. I'll show you how to bend it in a moment. Here I've panelized those staircases as well as a whole bunch of other parts. I have deck chairs and loungers, ladders, railings, vents, lookout platforms, tables, and the cabin for the cranes. When you send your files away to be made, there will be 2 types of charges, an NRE charge or non-recurring engineering to make the photo tool and set up the machines, and then a per piece charge that they'll charge you for each sheet that they make. For the sheet you see here, the charge was $27.30 US for the NRE and $12 per piece. I'll be sending these files to a company called Precision Photo Fabrication Developments. They suggest color coding the artwork so that anything that's supposed to be clear of brass is white, anything that's supposed to be full thickness brass is black, anything supposed to be half etched from the front is red, and anything that's supposed to be half etched from the back of the sheet is blue. You can send away your artwork like this, but if you can separate it out into a front mask and a back mask, you can save a little bit of money. Note that these aren't copied, they're mirrored. And 17 days after sending the files away, I received this package in the mail. These are first-class balcony doors and vent louvers, stairs, doors, and support pieces, ladders, deck chairs, crane canopy, some tables, a whole bunch of doors, a different kind of vent and first-class patio doors, and a few different kinds of railings. This is the artwork as I drew it, and the brass that got delivered. Some of the parts came in bent a little bit, but I'll be able to push these back into shape no problem. So now after the sheet has been primed and painted, I'm going to cut out this ladder, clip off the little tags, and fold it into shape. I'll start by bending the two sides so that they're parallel to each other and perpendicular to the stair steps. Now remember we had left a very small tag holding each stair step to the sides. That lets us bend each stair step so that it is horizontal. And this is our finished staircase. Another thing I have to make are these 4 cranes at the bow. The cabins are going to be 3D printed, but the booms all have to be made out of brass. They'll be made out of a combination of photo-etched brass and round brass bar stock. I'll start by cutting and trimming the parts and then cleaning them up. Luckily, I had made some extras. The round pipes on the top and the bottom of the crane boom are bent to match the profile of the photo-etched side. To solder these together, I'm going to apply some flux to the parts, and then clean the tip of the soldering iron if it needs it. Then wipe it clean on a damp sponge. The tip of the soldering iron should be bright and shiny. Then I'll touch a small dab of solder onto the soldering iron tip and tack the two parts together. And I'll do this in several different locations all the way down the crane boom. The goal here is not to make the finished soldering joint, it's just to hold the two parts together. And you can see it's a very quick touch of the soldering iron, so the heat doesn't have time to travel down the metal and burn your fingers. And now I can reheat these solder points and spread them out into the joint. It should flow nicely into the joint and leave a complete fillet with a shiny finish. If it doesn't, usually adding a little bit more flux helps. Again, the actual contact time is very short, so there's not enough time for the heat to flow down the metal and burn my hands. The two sides of the crane boom are joined together by a photo-etched end cap. And that is also tacked into position on the two crane booms, and then the solder is spread around the entire joint. And you do have to be very quick with this. First of all, so you don't burn your hands, and second, so that you don't unsolder parts that you've already soldered. The pivot point for the crane booms goes into these little holes on the cabin. So with the booms held the appropriate distance apart, I soldered a single piece of wire across the booms, then I'll cut it so it goes into the holes. And I'll grind down the jagged end of the cut. Then into some acetone before painting. And after painting, this is the result. These spacers have to go on after the booms are installed. And it's not really metalwork, it's plastic, but just to finish off the crane booms, I'll show it here. I'm not using all of my own photo-etched brass on this project. You can get commercial photo-etched brass for almost any subject that's out there. In this case, I'm going to use radars from some photo-etched brass that I had left over from other projects. And of course I had to clean the primer off before I soldered these. The procedure is pretty much the same for all soldering joints. Apply some flux. A small blob of solder on the iron, and touch it to the two parts. And in this case, I used a little bit too much solder and I filled some of the holes. So I'll use some solder braid to wick the excess solder off of the parts. These parts have almost no mechanical stress on them and their mass is almost zero, so it takes very little silver solder to hold them together permanently. And after all the parts are soldered together and it's painted, this is what it looks like. These sections with angled and curved walls are pretty complicated to make, and I show how to make templates for them in the superstructure video. Brass is a good material to make these out of. Because it's stiff enough to hold its shape, I can put details like windows and gratings in there, and I can add the railing at the top of the walls. I'll also use it to make these complicated cutouts and windows on the sides of the ship. I'll roll it against something soft like this foam and check it often to make sure that the curvature matches the superstructure. And this will be painted later. If I were to paint it first and then do the curving, it might crack the paint. This long section on the pool deck is going to be too long to make in one piece, so I'm going to have to make it in two pieces and then solder them together. The procedure is similar to the earlier soldering that I did, but in this case, instead of tacking the parts together, I'm going to tin the pieces with a thin layer of solder and then use a scrap piece of brass to attach them together. This solder butt joint will be extremely weak, but it's only meant to tack the two parts together until I put a stiffener on it. I'll tin the stiffener, put a small amount of solder on the soldering iron tip to help with heat transfer, and solder the parts together. The two pieces will always be held in alignment as long as you don't melt the entire length of the joint. And here's the joint side and the visible surface after painting. It's almost invisible. These pillars between the windows are where the lifeboat davits will attach, but I want something stronger than just a glue joint to hold these on. I put tabs on the davits, but I neglected to put holes in this brass for the tabs to key into. So out comes the Dremel tool. One interesting feature of the Oceanic is the Magradome, these sliding glass panels that can enclose or open up the pool area. This is a very complex structure that will be difficult to make, but it's a perfect application for photo-etched brass. These are the parts that surround the pool area. The railings are etched together with the floor that surrounds the pool area, so I'll use a device called the Etch Buddy to bend these up into a perfect 90-degree angle. You can see the tracks the Magradome panels will slide on are also etched into the brass. I've cleaned the parts, applied some flux, and now I'll solder these parts together. Now I'll add the two fixed skylights at either end of the Magradome opening. And now that I'm happy to be finished this section, I notice that one of the two skylights is attached backwards. This narrower side of the skylight should be attached towards the edge, like it is on this side. And since I've got extras of these parts, I'm just going to clip it into pieces to make it easier to remove without damaging the frame around it. And now it's repaired, and I'm going to test fit it onto the Oceanic and see how it looks. Now we'll move on to the rest of the skylight panels, and these are parts for one of 16 that I'm going to have to make for this model. These will be very fiddly things to build, but these tabs and slots will make it a lot easier to align the parts. I'll start by tacking the parts together as always, and then spread out the solder later. The parts don't have to be perfectly aligned here, that will come afterwards. Now that the two parts are held approximately in the right location relative to each other, I'm going to press it up against this block that I have glued down and use that to close this gap and hold the two parts at perfect right angles. I'll make a note here. If you do something like this, don't glue the block down with crazy glue. When that stuff gets heated up, like from a soldering iron, it makes horrible noxious fumes. Now spread out the solder to completely fill the gap. And we'll roll the two ends around a dowel so it matches up with the profile of the front and the back of these skylight pieces. I'll fill the joints at each end with solder. And then I'll move on to the thin pieces, which are done basically the same way. And here is one complete skylight panel. I'll cut the tabs off and then test fit it with some other panels to see if it nests properly. The client couldn't decide if he wanted to display the model with the Magradome open or closed, so I made him a version of each that he could just change at will. So those are some examples of the different types of metalwork we're going to use on the Oceanic. I hope they were helpful. And next time we're going to get into some 3D printing.